Hello students, welcome to Dr. Shoraf's classes. So in this particular class you see that we're solving this free response questions from this AP Calculus BC. Okay. So before moving on to the solving this question number 6, let us understand what is this FRQ, that is the first free response questions. So for most of the students who are taking this advanced placement, so this is one of the challenging part that you're facing, as it also has a significant amount of score that contributes to the overall score, so that in that case we can say that this is a significant portion of the total advanced placement exam. So since we are solving this AP Calculus BC, so for those students who are concerned about their marks in this particular subject AP Calculus, so here is a simple 5-point strategy. So this 5-point strategy, though it works for any of the AP, the advanced placement exam, be it in case of biology, English literature or calculus, so this 5-point strategy will work for each of the sections. So what is the first point? So first point is read the free response questions very carefully. So you have to understand what the question is demanding, the demand of the question. So for that you have to read it very carefully. And in case of point number 2, that is the second strategy, you have to maximize your points on the multiple part questions. Okay, so here you can see here the A, B, C, this 4 parts to this question given. So we will try to maximize the point on this multiple part question. Point number 3, you have to share your thought process. What is the approach you are taking? How we are going to solve this problem. Point number 4 is your clarity and your conciseness in solving the problem. There is a clear and concise idea. And point number 5 is the usage of the proper penmanship. So these are the 5-point strategy that I'm talking about. This, if you follow this strategy along with the most important thing, so you have to gain these skills. Actually, this is a strategy, you have to master this strategy only through practice. And the more important, in the point number 4, you can see the clear and conciseness, that is your clarity and your idea about the problem, how to solve the problem. So that will come only through practice, right? So without practice it's not possible to achieve this thing. So if you follow this 5-point strategy in each of the question that we will be solving, so I will follow this and will try to solve these questions using this strategy, and we'll see how effective it is. So if you follow this strategy and this 5-point strategy, and with practice, surely it will give you marks on the upper end. So I hope this solve your query. Those who are looking to improve your score in this particular FRQ section, so they can follow it, and I believe that they will surely get the result. So now let's move to the question number 6. So one thing to remember, that this graphing calculator is not allowed in this solving this particular questions. Okay. So let's start the question. So it is saying that the function g has derivatives of all orders for all real numbers. The Maclaurin series for g is given by this g of x, summation n equal to 0 to infinity minus 1 to the power n x to the power n 2 to the power n plus 3 on its interval of convergence. So you have to state the conditions. So let's start. This is 4 part of the question is there, so we will solve one by one. So let's start with the part A. It is given that state the conditions necessary to use the integral test to determine convergence of the series, that is summation of n equal to 0 to infinity 1 by e to the power n. Use the integral test to show that this particular series converges, that is the series n equal to 0 to infinity 1 by e to the power n, this particular series converges. So here you can say that e to the power minus x is positive, right? And it is a decreasing function, exponential function, decreasing function, and it is continuous on the interval, the semi-closed interval 0 and infinity. So these are the conditions, right? Now to use the integral test, to show that this summation n equal to 0 to infinity 1 by e to the power n converges, show that minus infinity to infinity integral of minus infinity to infinity, or it is since it is positive, so we can omit the lower bound, we can reduce it to 0. So integral 0 to infinity e to the power minus x dx is finite, that is converges. Okay, so that is an improper integral. Now to solve this, so we have the integral of 0 to infinity e to the power minus x dx. Okay, it is equal to limit b tends to infinity integral of 0 to b e to the power minus x dx. Okay, so solving this, we will have this limit b tends to infinity. So we have minus of minus e to the power minus x 0 to b. Okay, so limit b tends to infinity, we have this minus e to the power minus b plus e to the power 0. Okay, which is nothing but 1. So because the here you can see the integral, that is 0 to infinity e to the power minus x dx, it is converging. So we can say that the series summation of n equal to 0 to infinity 1 by e to the power n, it also converges. Okay, so that is the thing. So that is a part A. We have solved the part A, so that this series converges. So for this thing, the point distribution, so here we can see the conditions, 1 point. So we have determined the improper integral, and we have proved that the evaluation that the particular series converges. So these are the 3 points over here. Okay, so let's see the part B. So we have to use the limit comparison test with the series that summation equal to n equal to 0 to infinity 1 by e to the power n, to show that the series that g of 1 summation of n equal to 0 to infinity 1 minus 1 to the power n by 2 to the power en plus 3, it converges absolutely. So now we will solve with this part B. Okay, now set up the limit comparison. So limit n tends to infinity 1 by e to the power n by within mod minus 1 to the power n by 2 e to the power n plus 3. Okay, so that is equal to limit n tends to infinity 2 to the power en plus 3 by e to the power n, which is equal to 2. Okay, so that is the set of the limit comparison. Okay, so the limit here exists and is positive. Okay, therefore since the series summation of n equal to 0 to infinity 1 by e to the power n converges, then the series summation of n equal to 0 to infinity mod of minus 1 to the power n 2 to the power 2 into to the power n plus 3, this also converges by the limit comparison test, right? So thus the series, we can infer from here that the series g of 1 is equal to summation of n equal to 0 to infinity minus 1 to the power n by 2 to the power 2 into e to the power n plus 3, this also converges absolutely. Okay, we have shown it. So this is the, for the first one we have to set up the limit comparison. So this will fetch 1 point. So this will fetch 1 point, and the explanation part over here, so this will fetch 1 point. So total 2 parts for part B. Now part C. So we have to determine the radius of convergence for the Maclaurin series for G. Simple. So you have to find the radius of convergence. So that is our part C. So it will be now mod of minus 1 to the power n plus 1 x to the power n plus 1 divided by 2 e to the power n plus 1 plus 3. Okay, so here we have this 2 to the 2 e to the power n plus 3 divided by minus 1 to the power n xn. So that is the setting up the ratio. So it will be equal to, if we simplify this, it will be equal to mod of 2 e to the power n plus 3 into x to the power n plus 1 by 2 e to the power n plus 1 plus 3 into x to the power n. Okay, so which will simplify 2 into e to the power n plus 3 by 2 into e to the power n plus 1 plus 3 mod of x. So that is the setting up of ratio. Now, okay, now we have this limit n tends to infinity. So 2 to the power n plus 3, 2 to the power n plus 1 plus 3 mod of x. So that is 1 by e mod x, right? So that is the compute limit of the ratio. So from here you can see that minus this 1 by e mod x, it is actually less than 1. So in our case the mod of x will be less than e. So the radius of convergence you can easily find, that is the radius of convergence in this case, it will be r equal to e. Okay, so this will be r equal to e. So this is our answer. So for first part we have to set up the ratio. So this is 1 point. Next is the compute the limits of the ratio. So here we have find this is 1 point, and finally we have the answer over here. So this is 1 point, the radius of convergence. From here we get. So this completes the part C. Now let us check with the part D, how to solve this part equation. So what is the statement? So it is given that the first two terms of the series G1, summation of n equal to 0 to infinity minus 1 to the power n by 2 to the power en plus 3, are used to approximate G1. So using the alternating series error bound to determine an upper bound on the error of the approximation. So we have to use the alternating series error bound to determine, so alternating series error bound to determine an upper bound on the error of the approximation. Okay, so this is part D. So the term of the alternating series, that is the G1, that is given as alternating series as AS. So that is given as G of 1 is equal to summation of n equal to 0 to infinity minus 1 to the power n by 2 e to the power n plus 3. So it decrease in magnitude to 0. Okay, so the alternating series error bound, so to write in this manner, the alternating series error bound for the error of the approximation okay is the absolute value of the third term of the series. Okay, that will be the absolute value of the third term of the series. Okay, so what will be the error? You have to find this error from here. So that will be less than equal to minus 1 to the power then 2 to the power square plus 3. So we have given the third term of the series, so which will be equal to 1 by 2 e square plus 3. So that is the response for this. What is the error that you have to found for part D, and this comprise the total 1 point. Okay. So this is the answer for the part D, that is we have this 1 by 2 e square plus 3, and this solves the question 6 okay, for this AP Calculus piece.